A workflow is divided across multiple actors, each responsible for a segment rather than the whole. Completion is defined locally at each handoff point, not at the system level, so success is measured before the full task is actually finished. Each actor receives tasks without full visibility into upstream or downstream dependencies. This creates an incentive to prioritize completing their assigned segment quickly, because only that segment is observable and evaluated. Once an actor completes their portion, the system records a successful step, regardless of downstream readiness. That reinforces behavior where finishing the local task becomes the primary objective, not ensuring continuity. A gap begins to form when outputs are passed forward without alignment with the next segment's requirements. The receiving actor encounters incomplete or incompatible inputs, forcing adjustment or delay at the boundary. Instead of resolving the gap at its origin, each actor compensates locally to keep their own segment moving. This shifts effort toward patching incoming inconsistencies rather than coordinating upstream correction. The system still registers forward progress because each segment reports completion independently. This creates a visible signal of advancement even as underlying continuity weakens. What appears as distributed efficiency is actually fragmented execution across segments. Local success accumulates while system-level completion becomes increasingly uncertain. Actors begin to anticipate that downstream issues will not be traced back to their segment. This reduces the incentive to ensure output compatibility beyond minimum requirements. The system evolves into a sequence of loosely connected completions rather than a coordinated process. Each segment optimizes for throughput at its boundary, not for end-to-end integrity. As gaps accumulate, additional effort is required at later stages to reconcile inconsistencies. This shifts the burden of completion toward final segments, increasing their load and instability. Even when final outputs are incomplete, earlier segments still register as successful. This disconnect allows partial progress to be counted without system closure. It may seem that the problem comes from poor coordination or communication between actors, but the pattern persists even when communication channels are available because alignment is not incentivized. The actual driver is the structure that rewards segment completion without validating cross-segment continuity. Completion signals are detached from system completeness, allowing fragmentation to scale. Once this structure is in place, each actor's rational strategy is to minimize effort beyond their visible boundary. Ensuring full system coherence becomes an unassigned responsibility. Attempts to fix gaps locally introduce new inconsistencies elsewhere in the chain. Each correction shifts the problem rather than eliminating it, reinforcing fragmentation. Over time, the system stabilizes around partial completions as the default operating mode. Actors adapt to producing outputs that are good enough for handoff rather than sufficient for completion. The workflow becomes self-reinforcing, where incomplete outputs generate more incomplete downstream inputs. Each cycle deepens the separation between local success and global outcome. Even when the system appears active and productive, the final objective remains unmet. Progress signals continue to accumulate without translating into completed results. The equilibrium forms where no actor has both the incentive and visibility to close the full loop. System incompleteness persists because local optimization is consistently rewarded over coordinated completion. At this point, the system no longer fails occasionally. It reliably produces incomplete outcomes as a stable result of its incentive structure. As these gaps repeat across multiple task cycles, actors begin to assume that incoming inputs will always require adjustment. Instead of waiting for alignment, they preemptively modify or bypass inconsistencies to maintain local throughput, increasing divergence at each boundary. This anticipatory behavior reduces reliance on upstream precision. Outputs are produced with less concern for compatibility because downstream correction is already expected, widening the gap across segments. The system gradually shifts from sequential dependency to loosely coupled execution. Each segment becomes tolerant of incomplete inputs, allowing fragmentation to persist without triggering correction. Because completion is still recorded at each step, the system cannot distinguish between clean handoffs and patch transitions. This removes any signal that would incentivize restoring continuity, stabilizing the fragmented flow. As the number of segments increases, the number of potential gaps grows combinatorially. Each additional handoff introduces another point where local optimization can detach from system completion, amplifying incompleteness at scale. Actors facing repeated inconsistencies begin to allocate effort toward internal safeguards within their segment. These safeguards improve local reliability but further isolate segments, reducing cross-boundary coordination. Over time, segments evolve their own microstandards for what constitutes acceptable input. These standards diverge from each other, making alignment across the system increasingly difficult. When a segment tightens its own acceptance criteria, upstream actors are not required to adjust. Instead, the receiving segment absorbs the cost of mismatch, reinforcing the pattern of local compensation. This creates an asymmetric burden where later segments carry increasing coordination cost. Earlier segments remain optimized for speed, while later ones become bottlenecks, intensifying system imbalance. Attempts to accelerate throughput focus on improving individual segment efficiency. But faster local completion only increases the rate at which incomplete outputs propagate, deepening fragmentation. The system begins to exhibit a paradox where higher activity leads to lower completion rates. More tasks move through the pipeline, but fewer reach a fully coherent end state. At this stage, it may appear that increasing visibility across segments would resolve the issue. But even when visibility improves, the incentive to act on that information remains unchanged, leaving behavior intact. Information becomes available but not actionable within the existing structure. Actors can observe gaps, yet correcting them offers no direct benefit, so the gaps persist. The workflow stabilizes around a pattern where correction is deferred indefinitely. Each segment prioritizes maintaining its own flow, allowing inconsistencies to accumulate downstream. Over repeated cycles, the cost of achieving full completion exceeds the cost of maintaining partial progress. This shifts the system toward accepting incompleteness as the default operating condition. Even when a fully aligned output is required, it demands disproportionate coordination effort across all segments. This makes complete execution rare and unsustainable under normal conditions. At this point, the system's definition of success has effectively shifted. Progress is no longer tied to completion, but to the continuous movement of partially completed tasks. There is a structural tension in whether the system could ever realign around full completion. Correcting the accumulated gaps would require coordinated effort across segments that are not incentivized to participate. As a result, the system reinforces its own fragmentation with each iteration. Local completion remains optimal for every actor, even as system incompleteness becomes permanent. At this point, the system no longer rewards complete task resolution across the chain. It rewards the ability to finalize a segment and pass it forward, making local completion the dominant strategy for all actors. What was previously ignored, partial outputs that fail downstream, now becomes invisible within the system's success criteria. As long as each segment reports completion, gaps between segments carry no immediate penalty, allowing incompleteness to persist without resistance. Attempts to ensure full alignment introduce additional coordination costs that is not compensated within any single segment. This makes end-to-end completion a dominated strategy, gradually eliminating it from regular system behavior. Over time, the system begins to penalize actors who invest in cross-segment alignment through slower local throughput. Those who focus only on their segment maintain higher completion rates, reinforcing the separation between local success and global outcome. The equilibrium stabilizes where tasks reliably move but rarely finish as intended. Behavior converges on maintaining segment flow rather than achieving system closure, locking the system into persistent incomplete